For drainage in the landscape areas, we use what are called catch basins. Now there are two different ways to do this, but I prefer the catch basin. The first way is to have a 3 or 4 inch pipe that comes to the surface and it has a grate on top like you would have in the patio shot. What I prefer is what's called a catch basin. And the main reason we prefer that is because in a catch basin, the water can fall into the catch basin. It will be dirty because it's got different debris from the landscape, and the debris can settle to the bottom of the catch basin and the water comes up and then goes out into the pipe clean. Also, it enables me to use what's called an atrium grate. An atrium grate, as you can see, raises up above the landscape. Debris can cover the sides and then water can still flow over the top of the debris and get into the catch basin. When we have lawn areas, we use a flat grate. The flat grate is fine in a lawn area because the lawn stays cleaner, doesn't really have leaves in it, and so that's not getting covered with leaves isn't a real concern. But if we use this in the landscape, it can only take 1 or 2 leaves to cover the top of this and render it inoperable. So that's why we use an atrium grate in the landscape area. As you can see, debris falls into the bottom of this and then that settles at the bottom and the water comes up and goes clean. So this is the main reason we want to use catch basins in the landscape. This is a quick shot of an area drain. One of the main things here we want to look at is having it with a brass cover. Now many patios that I see have plastic covers, but unfortunately in the sun the plastic becomes brittle. Only takes one person with a high heel to go right through one of those. So I like to make sure we use brass. It also looks nicer than the white plastic in a beautiful patio. There are a few things about drain line I'd like to go over. The most important thing about drain line is to make sure that the water can move efficiently through the system, especially during high flow when it's really coming down. We don't want any debris or interruptions in the system. What you see here is some old corrugated pipe. This is a product that I've never cared for very much. I find it a lot in older jobs. This job that's being redone right now, they had this in the ground, and you can see some of the reasons why we don't use this. It's been partially crushed and actually rips pretty easily compared to this PVC pipe. Also, one of the things I don't like about it is the inside corrugations tend to trap debris. Instead of the debris being flushed through the line with the water, they get trapped in these corrugations. It starts to build up and then you get a lot less movement. Also, it's harder to get a good slope on this because it's flexible. It will tend to undulate in the bottom of a trench, and again it traps water and moves the water a lot less efficiently through the system. Over here you see where we've tied in a downspout to some drain line, and this is a downspout adapter. Once that gets into the ground, we like to use what's called a sweep or a Y. This has a 45 feeding into it, and the reason we use these instead of a T is so that the water is moving in more of a fluid way. If the water can move this way through the pipe, it's going to flow a lot better, and it's also going to carry little bits of debris through the pipe better than if this dropped into a T and things got kind of jammed up in there and then had to be carried away. That's especially important if you don't have very much slope on your pipe, which can happen in flatter yards. So this is, and this PVC is rated for 3,000 pounds, which is very different than the corrugated pipe. Then this last type of pipe is a perforated pipe, and the reason this is used is for French drains. This allows water to feed in through the bottom of the pipe, and then it carries off and is fed into a solid pipe once the water is collected. Retaining walls have a few common elements that I'd like to cover now. Whenever we have a downslope into the back of a retaining wall, what we want to do is relieve the pressure that builds up from the weight of water from behind that wall. So what we see here is a French drain configuration, and if you look at the diagram, you'll see some of the 3 elements that make that up. You have perforated drain line at the bottom of the French drain, which collects the water as it settles to the bottom of this drain. You have gravel, which allows air to enter the drain configuration so that water will drop to the bottom. And then you have a filter cloth wrapping around the gravel bed as well as the pipe, and that keeps debris from filling up and clogging the French drain configuration. The other element that's common is a water backing, or something that will make the back of the wall watertight. There's a few different ways to do that. We can either use like a asphalt emulsion that is actually painted on the back of the wall, or as we see here, there's actually a rubber membrane that's been nailed to the back of the wall. It will sheet down the entire back of the wall and sheet the water into the lower pipe at the bottom of the French drain. This is an example of efflorescence moving through a retaining wall. Efflorescence is a result of water moving through a concrete wall, or a concrete slab for that matter, and when the water moves through the wall surface, it brings lime and calcium with it. This is a clean out which also connects to the bottom line, and what this allows is for somebody to come in and maintain that French drain by flushing water through it. This goes down and forms a Y right into that French drain line, and they can flush water and any debris that may build up out of the line. So those are the components that make up a French drain.